Hi all. So today our topic is like arrays, and from here we can say from this class, DSA has almost started. Okay. So what is DSA? Data structure and algorithm. I hope everyone knows it, but let's try to break it down. Okay. DS means data structure, like how efficiently you are storing the data. Okay, that is itself a data structure. So now you are learning arrays. When you move forward, you will be learning trees and all those stuff. So here, what is the data structure means how efficiently you are storing the data. Algorithm is nothing but how efficiently you are extracting the data from this. Okay, so you have now stored all the data. So how efficiently you are extracting data from this is nothing but an algorithm. Okay, so today's our first data structure that we'll be learning is arrays. And the algorithms for this will like what we'll be doing is like, let's say linear search, then binary search. So few algorithms. These are the algorithms which will try to extract the data from the arrays. Clear? Okay. Now let's come to the topic as arrays. Okay. So for to understand arrays, let's first imagine like you had few data, like let's say you had few marks of your subject, like let's say you have physics, chemistry, and maths. So if it were just few variables like this, then it's easy to store. You can just create a variable like this and you can store whatever it is, like 100, 98, 70, something like that. Okay, but let's imagine now your task is to store all the marks of your school subjects. So you'll be having like social science, science, English, and sem-wise it may keep on changing, right? Then that time it's not efficient to create variables like this. Okay, why? It's very hard to again track it all. So it would be better if we could have a place or a somewhere location where we could have store all this data in a sequential format, like in an order format. So whenever we want a particular data, we can extract. So to solve this problem itself, the arrays is taking place. So how array stores the data is that whatever you write the data, this can be stored it in like this 100, where it will be 98, and it will be like 70. Next subject you have like let's say again 90. So here you can keep on storing the data. And whenever you want any particular data, you can just refer to their index. So what is index? Now this entire thing is an array. Okay, this entire thing is an array. And this index is nothing but the first value will be in the 0th index. Okay, the second value will be in the first index, second index, third index. So up to nth index. Okay, clear? So in this way, like whenever you want any, like you know that in 4th index, I have some value I have to extract, you can directly go to that particular location and you can extract that date. Clear? Okay. So again, before starting to code, let's try to visualize a bit with the help of like what actually happens in the memory. So let's say like we already know in memory that the data, like here we'll be storing it like in 1 byte will be there. So 1 byte is what 8 bits that we had discussed in initial classes. So the the memory location will be in this format. Okay, so whenever you are creating an array, okay, first of all, what is the definition of array? We can say, let's first define the array. Arrays, you can say it as a list of elements of same data type. Okay, list of elements of same data type. So here the data type is what? Int. You can't include string data, character data in this. You can't include that. Okay, this is not possible in Java. The elements, all it should be like string, all it should be int, all it should be character. Okay, that is the first part. And the second, let me again continue. So array is the list of elements stored in a sequential format. Okay, or we can say in an adjacent format. So what does this mean? The last statement. That means when in the memory, if let's say this is a integer list and it has 3 datas, let's say I have a array 1, 2, and 3. So these are stored in this format. Okay, and in memory, the location are in adjacent. Let's take this first memory location as anything. Let's say we'll take it as 500. The next memory location will be 504. The next will be 508. If it was 1000, The next one will be 1004. The next one will be 1008. How this one? How did I get this 4 and 8 as last number? Because I hope you remember when we discussed in initial classes, int will take how many bytes? Okay, how many bytes it will take? It will take 4 bytes, right? 4 bytes. So here, 4 bytes of together will make one box, and in this entire box, what data is stored? Our first data, that is 1. 1 is stored here. So 1 is stored here, then 2 is stored here, and 3 is stored here. Right? Yeah. And this is different from this. Here, this is known as index, which we refer for that position. This is somewhere as memory location. How to locate here? With the help of like a new keyword will be there, which will give us a place. Any one place it will give. And from there, we keep on creating our datas. Okay. We keep on locating all our data. Clear? So I hope you have got still here. So theory is done. Let's now practically create a array. So before creating, let's try to understand the syntax. So first and foremost, we have to always write the data type. Okay. Why? Because Java is which type of language? Typed language, right? So we have to write the data type, then the array name. So let's say a name I'll give for that. Array name, you can give it anything here. Then a square bracket. Clear? Okay. After giving square bracket, here we have to give the new. Why new? This will allot a memory space in your memory location. So something like that you can think. So it will create a new. And after this, what you have to do, again, the data type, whatever you have mentioned here, that data type, data type. And then you have to mention the size. What size of data? Let's say you want to store 5 data in your array, then you have to mention as 5. Okay, this is the one process. Or the second step you can say is like if you already know what data you are storing, you can simply say data type again. Data, oh my god, I do it. Okay, data type, then array name, square bracket. And here, if you already know the data, let's say like 40, 50, and 60. So these are the like some data. Let's do 68. These are some data which you want to store. So you know the data, right? And you want to store only 3 data. Then you can directly give curly brackets and you can say 40, 50, and 68. Okay, so we just saw 2 ways to store the data and create an array. Let's first try to do this. Here, I'll first create a int type of array. So in which all the elements are of integer type. So I'll say int. Array name, I'll say as list array. List of int. List of int. I'll say square brackets, I have to say. Then what I have to say? I have to create a new. And then again, I have to say the data type, which it is int. And here I have to say, let's say I want to store 5 data in it. Okay. And I just created a array whose name is what? List of int. Okay. And now if I just try to print it, it will just display an empty array, which is nothing but it will display all 0, 0, 0. So let's check it if it displays in that way. List of int. Let me run it. So, oh, sorry. And one more thing. In Java, we can't directly do like this. In Python, if it was a Python, you could have directly given the list name and it prints. But as it is a Java, so this is not the valid step. Here we have to use a loop. So I'll say for x, I have to initialize int x equal to first it is 0 because our index starts with 0. Then x go up to x less than list, whatever is my list of int dot length. So go up to that and keep on updating my x. So x plus plus. Okay, so once I have done this, next line, and here what I have to display is nothing but my list of int, right? So I'll just copy this now, list of int. I will do south. Oh shit. South. And here I'll display list of int, and inside this bracket I'm giving x. What will be the values of x? It will start with 0. Next time it will be 1, 2, 3, 4, and so on. So if I run it, so now if you see, I get all the values of my list array. Okay. That is nothing but initially all are empty, which is having like a data 0 in it by default. Clear? Any doubts here? So this is nothing but like you can also, if you want to separate data to be printed, you can also do like this. So south list of array, you want to know what is in the first position, you can just say first as in this, and you can just comment this. So let's see what is there in first location, which should be obviously 0. So here we should get 1, 0. Clear? So you may have got an idea, like if we are using this for displaying, then obviously this itself we have to use to store the data also. So in case if you want to manipulate it, like if you want to store the data, then what you will say, in the first index, that is nothing but the second position of our array, store, let's say 8, the integer 8. And if I run it, now you see 8 is being stored. Similarly, I can do for other positions also. So let me duplicate it. Here it will be, let's say 2, T, and we have a last one as 4. Here I'll do it 81. Here I'll do 84, 78, something like this. Okay. And now I'll comment this one because I want to check the entire array, and I'll uncomment the for loop. And if I run it, here in first index, we didn't store anything, first position. So it just displayed as 0 as it is. And whereas in the rest, it displayed the values. Clear? You can take the input also and store. So those are our basics. I just did it in a short way. Clear? So once we have understood this, and in case, as I was saying, if you already know these data, that these are the data that you are going to store, then what you can do is you can also initialize it in this way. So let me say int list of known, okay, let's keep it this much itself, list of no. Here what I'll say is, let's say I have to first of all keep a square bracket, so it's considered as an array. Okay, no matter if here, even if you give as many spaces, there's not an issue, but it's actually no spaces will be there inside that. And after that, what I know, I already know the value. So here I can directly give like this 7, 54, 65, 8, something like this, and close the parentheses. So list of known is done. And if I just want to print this, Control C, and here I'll just change this to list of known. Okay, so start the loop with 0th position and run up to the list of known is less than the length of list of known. Okay, and keep on updating it. And here I'm just displaying it. So I should be able to display all this value one by one. Yeah, if you want to just display in one line, you can remove this println. And after this, you can add plus. And now this will be displayed in a horizontal way. Clear? Okay, so what we just saw is we saw how to create, first of all, our list, and then how to store the data inside there. Okay, once we have understood this concept, and we also know how it is occupying the memory. Okay, in memory location, how it's occupying. So if it was by chance, let's say for string, I can also create a list. Let's have one example for that. So let's say I'm creating a string data, string list. So list of string, if I do it like this, square bracket equal to, I already know my values. Let's say my first value is apple. Then I can say mango. Then I can say orange. Okay. And here I'm ending this, and here I have to say what? I have to create a new, which I just removed. And here I have to say string. Hey, wait, what I'm doing? List of unknown. So, oh yeah, the string S is small here. Okay, so it happens a few times. Right, so string, list of string, apple, mango, orange. Okay. And if I try to display now, I'll just take this list of string, copy, list of, no, I'll change it. I'll change this. And here, apple, mango, orange. Let's try to put this in a function because every time we are changing this list name, right? So instead of changing that, let's have a function for this to display our list. So I'll create a public static function, public. What is this? We'll discuss this in oops class as state. And how do we create a function? We say public static, and then the return type, what is returning? Presently, do we want something to be returned? Let's not return anything from this. Let's try to display only. And the function name is, let's say, display array. Okay. And here, what is it's going to take? It's going to take the argument as, what should we pass? We should pass the list. Okay. So I'll say string as arguments. And again, I have to clear this string as arguments. Once done this, what I have to display? I have to write this for loop there. So I'll just copy this and I'll cut it. I'll paste it here. And this string of this should be displayed with, let me make it a list, which will sound good. Copy and change this to a list and change this to a list. Okay. And for this, what I'll do is display array. I call it here. Display array. And here I am going to pass my list of string. And I'm going to end the statement as this. And if I run it, I should be able to display, able to see apple, mango, orange. And if I run it, you are able to see apple, mango, orange. Okay, clear? Okay. And in our last class, we had discussed one topic, right? To create similar functions. So here I can do the same thing. And here I can change it as int. And now it will be int. So I can pass the same thing. I can just do this duplicate. And now I can also pass list of int for the same function name. Okay, I need not change the function name as display array int, display array string. Okay, I have a same function, but I have just changed the arguments data types. Okay, and if I run it now, so if you see, I'm able to see 0, 8, all this stuff. Okay, let me add a out here. So it's displayed in next line. And if I run it now, so first we have apple, mango, orange, then we have the numbers. Clear? Okay, so I hope you have got till here. Now, what we'll do, our next task is now once we have understood to create the list, now let's try to try to search one element from that list. Okay, so that is nothing but we'll do our first this linear search algorithm, we can say. Okay, for that first I'll again create my list and let's say my array name is ls linear search linear array, or I can say simply list array and here square bracket and equal to let's say I'll give some default values as 7, 8, 5, 64, 25. Okay, so I've created an array. Now, what I want is I want a algorithm, I want a function which should tell me in which index a particular element is there. So if, for example, if I pass 64, it should tell me it is in 0, 1, 2, third index. Okay, that is the function task of the function. So for that, what I'll do is I'll create the function first, that is public. Then I'll say static. Then I'll say, do I need to return something? Yes, here I have to return. What I have to return? I have to return the index. So I'll say int. And then what's our function name? Let's say it's linear search. And here we are going to take the arguments, that is first int, square bracket, that's nothing an array. And let's say this is an list. Okay, this is list data. Okay, once I have done this, now I am going to write the logic. Okay, for time being, what I'll say, I'll return -1 by default. Okay, I'll close it. Now, before writing this code, first let's try to think like how the linear search works. Okay, so for that, let me just draw this. So I have a list which is 7, 8, 5, 64, and 25. Linear search is most easiest way. Here we are just going by element, that is index by index we are going. And whenever we get a particular key that we are searching for, we'll just stop our search here with the help of break statement. And then after stopping this, what we'll do is we'll return the index of this. So that is nothing but 0, 1, 2, and this is 3. So we'll return this as 3. So to go through each element by element, we have to use the for loop, and to compare inside that, we have to use the if condition. So let's try to do it. So let me write a for loop here now. For, let's say this is starting with int x equal to, I'll start with 0 because index starts with 0. Go up to x is less than list data dot length, that is go up to the length of list -1. Okay, then what I'm doing, I'm updating my x so that we are moving forward. Once I do like this, now what I want is the if condition. So here I'm checking if what list data, Control C, conditional, I have to put parentheses, list data square bracket is my x. So this will go through each item by item, and this I have to compare it with a element, right? Now for now we have 64, but every time this won't be a 64. We also want our function to take a argument. So here it is a parameter, to take a parameter which is a key. Okay, so I'll say int key. Okay, so this will take a key. So we'll compare if it is equal to key. Then what we'll do is we will go inside this if condition and we'll return what? We'll return the x position, and we'll say this. Okay, so if this worked, like if we found 64 in the list, then we are going inside this if condition and this is getting executed. In case this was not executed, let's say, for example, we searched for a number 7. 7 is already there. We searched for 10. So it will go here first. No, not there, not there, not there, not there, not there. So there is no 10 present inside this itself. So this if condition will never be executed. So there will be never a return condition from here. Then obviously once this loop is completed from here to here, it will go outside. And here by default, we are returning what? -1. So we can write a condition. If it is a -1, then we can print it as what? Not found. Okay, what is not found? The key not found. Key not found. Okay, again, if you are from Python, -1 is an index, that is a negative index. Like we can start from backwards if we start, that's a -1. But in Java, we don't have anything like -1 as an index. So here we can return -1. Okay, clear. So let's try to clear this stuff and let's try to code it. So, okay, the coding is already done. Now let's try to implement it. So I have a function linear search. Okay, so I will say, I'll create a variable which is of int, because here we are returning which type of data. These are integer type of data, right? So I'm creating a data type like int, and I'm telling the index, I can make meaning index. And in this, what I have to store is whatever is the output from this linear search. So I'll copy this linear search. What I have to pass? I have to pass my list data. So that is nothing but my list array for here. Control C. And that I'll pass here. This is my first argument. And after that, what I have to pass is a key. What is my key? Let's say 64 I want to find. So I'll enter 64 inside this. And then I'll end this statement. Once I get the data in this, I'll put a if condition here. If index, oh my god, index is equal to -1, what I can do is, let's say, south, what I'll south, key not present, key not present. Okay. If you want to write it in detail, then like what you can do is you can create this variable like int key equal to here, whatever you want to search, that you can take it with the help of input. Presently, I'm writing 64 itself. And here I can say what key plus what I can say not present in. If you want to give list array, you can give list array, or you can say simply not present in array. Okay. Or else what I'll say, else south, what I can say, key, key, let me write here, plus present in index. What is the index? For that, I'll say plus. Where will the index value stored? In this index. Okay. So I'll say plus index. Yeah. And if I try to run it, so 64 present in index 3. So if you see, it's in present in 0, 1, 2, and in third index, it is present. Let me give here /t. So yeah, and let me give here also /t. What is /t? It will give 4 spaces. If you want 4 spaces, you can give 4 spaces, or you can just give a normal space like this. And if I run it, so 64 present. Oh, I don't like this. Or let it be. It's fine, right? Okay, let's keep like that. I just wanted to show like when this is the /t or something. So I used that. And let's try to enter something which is not there, like 10, and search it. Clear. So 10 present in index. Oh, did you get the issue? The issue was here I'm passing 64 itself, whereas I have to change this, right? Control C, and I have to change this. So, okay. So once, like, whenever you are in a flow, like creating variables and all, then that's good. But once you create a variable after writing a program, then if you forget to update, then these are the silly mistakes that happens. Okay, what I had done is I had created a key element here, but I didn't update it at this argument. So that was the error. Now if I run it, so 10 not present in array, and that's what we are expecting. Okay, cool. So it completely worked. Okay, yeah. So the next algorithm is binary search, and it is much more efficient than linear search. Okay, if you ask me like why, because if you try to, let's for understanding this, let's try to take the example of dictionary. Okay, and if I gave you some word, let's say like maid. Okay, how will you find it? Will you go from starting A, B, like A page, B page, or will you come from ending like X, Y, Z from Z? No, right? You could directly pop in between somewhere, because you know M will lie between. It's not even in starting and not even at ending. It will lie somewhere in between, right? So you will directly jump in middle pages, and you will try to check if there is somewhere made present, right? If you could have started from beginning, like A page, B page, you could have gone, then this would be referred as linear search, because you are going linearly, right? And this could take a lot of time. But what you did, you jumped directly in between, and you are comparing, like, is it in this side or is it in this side, left side or right side, right? The same concept, the exact concept is being applied in binary search. That itself is a binary search. For example, so here the only condition for binary search is that it should be a ascending format or descending format. Okay, like it should be sorted basically. Right. Once we have a sorted array, for example, I'll create a sorted array now, 1, 4, 10, 17, 50. And let's take 2 more. So 61 and 101. Okay, let me remove this one, not one. So now I have a array, which is basically in a sorted form. So to start with binary search, what we want is we want 3 points. First one is the starting point. The second one is the ending point, right? And once we get these two, the third point is the middle point. So what will be the third point here? So this 3 is left here, this 3 is left here, and let's say this is our middle point. Now, once we get our middle point, we will first check what is our key. Let's say in this key, we want to find out 4. Where is 4 in our array? Like in which index 4 is present. If this is our case, then what we'll do? When we'll get this midpoint, we'll compare. Is this equal to the key? No, it's obviously not. So then if it is not equal to key, then we'll check. Is it less than, is it greater than the key? Sorry, here it is mid, right? So is the mid greater than key or is the mid less than key? Okay. Now what is happening? Mid is what? Mid is greater, right? Greater than key. That means the key should be somewhere be in the left side. Right? If the key is greater than the mid, we know that it should be somewhere in the right side. Now basically it's in left side. So again from this, what we'll do, we'll break our array into subparts. So we'll ignore this. We have our start point as fixed. When we are going to the left side, what we'll do, we'll just update our end point. So this will be our end, which is nothing but our mid, whatever is the mid, -1. And then afterwards, we'll again check. This is our midpoint, new midpoint. So here, whatever logic you had applied here, the same logic will apply here. So if you see here, now it's equal to key itself. So here we are going to return the position of this index, right? In case if it was 101, if it was 101, then what would have happened? Yeah, we could have first checked, got this as a mid. We could have compared, like, will it be in the left side or the right side by comparing? If it is greater than, then it will obviously be in the right side. So once we declare the right side, here what we'll do, here we'll update our start point. Okay, the end is fixed. Here the start was fixed. Here end was updated. Now here what we are updating in the right side, start is being updated. And here how it will update, we will say mid +1. Clear? And once we get, this will be our new mid. So even if this is not the, like here, if we see now 61. So this condition is not being satisfied. And here mid is greater than key. This condition is being satisfied. Therefore, again, we'll jump to this side. And here, if you see, here we have only one element. So this itself is our starting, ending, and mid. Clear? And when it is mid and we got this condition as true, therefore we'll say it is at the last index, right? Or whatever the index number is. Clear? In case if none of the condition would have been satisfied, then by default we'll return -1, saying that the key is not present in the array. Clear? So let's try to do this. So what we'll do is we'll create an array first of all, a dummy array. So for that, I'll say int, and then I'll give an array name, let's say list data, and I'll create a square bracket saying that it's an array. Then I'll store some default values, let's say 1, 3, 5, 32, 34, okay. And let's give 432, okay, it went too big, and 876. Clear? So once we have this many arguments, okay, now if you see here we have, okay, it's odd itself. Now what we'll do is we'll create a function. I'll say public static. Okay, then our function name would be, let's say, binary search, right? We are doing a binary search. So binary search, right? And we have to specify what data is being returned. So here, from here, we are going to return our index, which will be of integer data. And what arguments we are going to take? We are going to take the arguments as an integer, as a array, which is of integer data right now. So I'll say int, then let's say the array name is as list. list array, and it's of square brackets I have to give because I have to mention this, it's array, and we also want a key. Okay, so int key. Once I have these two as my arguments or parameters, now what I have to do is, first of all, we discussed we want the starting point and ending point. So let me first declare that int start. So start we know is by default 0. Great. Then what I'll do, int last, I'll say last is equal to, here last, how I'll say, whatever is my length of list array. So list array dot length. Okay, but only this much is not enough. Why? Because here now what it will give, 1 2 3 4 5 6 7, it will give the 7 as length, but we know the index will be up to 876 is in the index 6, not in 7. So what we'll do, we'll do -1. Clear? So once we got our starting point and ending point, here I'll do a conditional based loop. Okay, so that is nothing but while what I'll say, my start is less than or equal to list, last. Okay, so if this is true, why did I give equal to? Because we saw if it is at the last, like only one array is there, like one element is present, like we have passed an array which is having only one element inside it. Then start is itself that, last is also that. So if to take that condition, I have given equal to also here. So I have start, I have last. Now next, what we have to do, we have to find out the mid. So I'll say mid, int mid, what I'll say, mid equal to whatever is my start plus whatever is my last. Okay, I'll add these two. After adding this two, I'll take the half of it. Clear? Now what we got mid. What is mid? Mid is the average of like start plus last and divided by 2. As it is an integer, we'll get a proper index itself. So once I get that, what I'll do is I'll put a if condition now. If my list of array, okay, I'll give the condition list of arrays mid value, whatever is the mid, I'll put it inside this mid is equal to whatever is the key that we have passed. So I'll control C, key whatever I have passed that. If these both are equal, what we'll do is return the mid. Okay, because mid will be nothing but the index of that. Okay, so keep on doing this. But we have to also update our what? Start and last. Okay, so here I'll write the condition for that. If how to write the condition? Let's say list of array. I'll copy this. List of array of mid is greater than key. So if this is happening, what I have to do? That is nothing but let's draw again. So here I have 1 2 3 4 5 6. Let's say now 7 I'll take. Now this is our middle value. Okay. Now what I am taking, let's say our key is 2. Key is 2. Now middle is what? Middle is 4 and key is 2. So 4 is greater than 2, right? So here, if this condition is achieved, what I have to do? I have to update my end only. So I'll update my end here. So end equal to mid -1. Correct? Okay. I don't have end variable itself. I have the variable as last. Correct? If this is not happening, then what I have to do is I have to do else if condition. Else if control C it is greater than this, then what I'll do? I'll update my start. Here, if this is not happening, then what is the next condition? Oh my god, where is my pen? Yeah. Then I have to update my start to check in this range. Okay, so this will be the start, right? So here how I got start. this will be whatever is my mid plus 1. Great. So I'll just update my start. So start equal to what is my mid plus 1. Clear? So I'm updating this. So keep on doing this. If there is a scenario like it kept on updating and it got up to the last value. So if it came up to this last value and further it's not possible, condition will be now false. So then what we'll do is we'll return as -1, which is saying that there is no key present in our array. Clear? So this is our while loop and this is the return statement here. So if it is middle, then only we'll send the index, or else we'll keep on finding like if it is in left side or right side. And yeah, that's it. Now let's test it. So I'll directly use south, and then I'll say what I have to call the binary search function. I have to call Control C. I'll call the binary search function. I'll have to pass 2 arguments. My first argument will be list data. So I'll pass it here. And then my key, let's say I'll pass it as 5. Clear? And if I put it now, if I run it, let's see if it gives the correct answer. And it gave me the answer as 2. Is it correct? So the first one 0, 1 and 2. Yes, it's in correct index. Now let's give 34. Just 1 second. 44. So fourth index 0, 1, 2, 3, 4. Yes, 4. What about 876? Uh-oh. Oh no, wait, I have to update this, right? 876. And let me do, okay, 876, it's 6th. So 0, 1, 2, 3, 4, 5, 6. Great. And let's enter some values which is not there, like 1000, which is not there in our array. Then for that, what we are returning -1. So for that, we have to give the condition actually, but let's, okay, -1. Right? So you can simply give a if statement here saying that if the return value from this binary search is -1, then basically it is a index is not there. The key item is not there in that array. Clear? So this was a simple binary search. Okay. Now let's compare the linear search and binary search. Okay. We'll be having separate time complexity and space complexity, like all that separate class. But for time being, let's have a brief idea, which is taking much time. We always calculate time complexity based on worst case scenario. Okay, worst case scenario. So in linear search, what was the worst case? Like it has to travel up to the nth item, right? If the array length is 100, it has to go up to 100. So whatever is the length, that is the n, it has to travel up to that. So the time taken here somewhere was like O to the O n, we say. Like, but in binary search, what was happening? We are specifically like dividing every time. So if it is like n, first we are dividing it. So now we have n by 2, and here we have n by 2. And in this, we again divide. Now, if it is in this range, what we'll do, we'll take only this much part and we'll again divide it. Now it's already n by 2. So here it will be n by 4. Once we do n by 4, now we'll again check if it is in this part. So if it is in this part, here we'll again divide it. So this will be like n by 8. Clear? And here, if we get somewhere the value, then we are saying we are returning from here. So if you see here, it's not taking, it's not going up to the nth iteration. Here we are keep on dividing. So let's write it in this format. So the same thing can be written like this: n by 2, n by 2, then it is becoming n by 4, n by 8. So it will keep on happening like until we get a value like somewhere 1. Okay. So now if we try to understand, this can also be written. Where is my pen? Okay. Yeah. As this is nothing but all are based off 2 itself. So this is like n to the base 2 1, 2, 2, okay, 2, and to the raised to 3, and so on. Here it will go up to 2 by k, where this will be value of 1, right? And we are going to take this value itself to find the time complexity of this. So if I take this part here, what it is, 2 raised to k equal to 1, okay, which is n by 2 raised to k equal to 1. So this can be, this is nothing but this can also be written as what it is, n equal to 2 raised to k. And if you know like a bit of maths, which will, again, this everything whatever I'm doing now, it may be like bit fast, I can say, but you need not worry. We'll again do it in time complexity separate chapter. There I'll explain properly once again, but let's complete this part. So here if I summarize this, this is nothing but I'll get it k as log to the base log n to the base 2. Clear? So this is nothing but this can be generally written as O of log n, right? And if you compare any number, n is always greater than log of n, right? N is, so from this we get to know that n is what? N is of linear search. So time taken for linear search is always greater than time taken for, what is this, binary search. Clear? Great. So this was a brief comparison between linear search versus binary search. Okay. So now we have a task to find out the largest number in a given array. Okay, so let's have an array as something 100, 1, 2, 20, 22, and 1, 7, 30, 13, 36, something. A random number, I took any number. Okay, and now we have to find out, okay, let me give here 360, which I'll randomly increase 172. Okay, so here we have our largest number. Great. So what I'll do now to find out this, first of all, what we'll do, we'll start with the least value. And here with the help of Java module, like there is a maths module from which we can get the least value, that is nothing but the minus infinity. Okay, so once we get this minus infinity, what we'll do, we'll create a variable as largest, and we'll store in this, first of all, the least value, that is minus infinity. And once we store this, we'll go on comparing through our each item in the list. Okay, and anywhere if we find a number which is greater than a value that is present in largest, we are going to update that. For example, initially it is minus infinity. Now, when we compare it with the first element, that is 101, which is greater? This is greater. So we are going to store 101. Okay, we are going to remove this. After that, we are going with next number, that is 22. Is 22 greater than 101? No, will not store this. Is 1? No. Next number is 172. So when we compare 172 with the variable that is largest, because this is the having 1, not 1, 172 is greater. So what we'll do is we'll remove this and we'll store 172 in our variable. Which variable? Largest variable. And once we store it, then again the process will continue. So 13 will also not be stored and 36 also will not be stored because they both are less than 172. So finally, what we have an output where our largest number is what? 172. Clear? So this was a simple logic. So here what we did, here first of all, we require a for loop, or you can use while loop also. If we require a loop, which will help us to go through item, like list elements one by one. And second, what we want a if condition to check continuously with the variable largest. Clear? So let's try to first, let's try to code it. So what I'll do is, first of all, I'll create an array. So int, let's say the array name is ARR and square bracket. And here I'm going to create, let's say randomly 232, 89. Okay, so I randomly typed a number. I'll close this, and here I'll create one more, what it is, I have to create a variable, right? In so largest largest number. So here what I say equal to integer dot min value. So if you see, this is by default present in. Okay, if we have not, so to get this, what we have to do is we have to import one library, that is import java dot util dot all. So in this library, this is present. So we need not worry of that. And once we get this, now we have to go through the loop, right? We require a loop to go through our array. So what we'll do is we'll write a for loop. So for, let's say in x, I'll say equal to 0. So I've initialized it. Then I'll go up to where I have to go, up to it's less than the length of our array minus 1. So my array dot length plus plus, right? And then what I'll do is I have to use a if here. So if what we are comparing our largest number with the values present inside this. So for that, I say, first of all, largest number is easy to write. So I'll write largest number, control C, largest number. Oh my God. Okay, let me type it, largest number. And here, whatever is what we have to do is we have to say if largest number is less than the array of, control C, I'll put it here, array of what? X. So X will keep on changing the values. So I'll write X here. Correct. And then what I'll say, if this case happens, so whenever the largest number is less than the array of X, then what I'll do, I'll simply update my largest number. Largest number is equal to array of X. Control C and control clear. Follow. Great. So this loop will keep on running up till it reaches to the last point. So once this has done, at last what I'll do south. I'll say largest number is. So what is the largest number? Is the largest number, presently largest number. So if we run it, okay, so the largest number is 556. Correct? So let's try this 897. And if I do like this, and if I run it, correct, 897 is the largest number. So now this, instead of coding here, I can create a separate function for this, public static. Okay, I can say get largest. And in this, what we are going to get is, first of all, we require one variable, that is array. Control C. We require a variable as int. Okay, and once we have this array inside this, what I'll do is I'll copy this entire part, what I've written here. Control X, Control V. This state, this what is required is I'll Control X and I'll give it here itself. Okay, I have to call this function, that is, okay, I have forgot to write the return type. So here I'm going to return the int. And what else I forgot? I have to return the values, right? So I'll return the largest. Okay. So once I return this, now here I'll create again the same variable. So, or I can say it's simply largest. So I'll say int largest target. Okay, let it be. So I'll say get largest. Control C. Get largest. So what I have to pass? I have to pass my array ARR, and yeah, that's it. So close it, and now if I run it, it should still work fine. Yeah, 897. We can similarly do for the least value. So for that, what I'll do, smallest, I'll say smallest, and we'll start with max number for that. and we have to go on reducing up to we get the minimum value. Okay, so here again I'll write a separate if condition. If what it is, smallest number is, let's say, greater than what it is, array of x, arr of x. If this ever happens, what I'll do is I'll update my smallest num equal to what I'll do is array of x. Yeah. And after this, what I'll do is I'll simply print here. So what I'll do is smallest, because we can't pass now to this right now, because here I said int. So I can't pass two values. So smallest now. So let's try to run this once again. See, 5 is being printed. How it printed? It printed with the help of this statement. Yeah. So here we got the 5, and here the largest is being returned with the help of this. That is nothing but 8 negative. Clear? So I hope you have got this. So yeah.